Hi, I'm AMALINA AZIZ. Today I would like to present my poster entitled Review of Synthesis, Characterization and Cytotoxicity Study of Organotin Dithiocarbamate Compounds. Organotin compounds have been discovered for over 170 years. This compound is forming through chemical bonding between tin and carbon atom, which they are presented as the following general formula. Currently, organotin have become an industry. This is mainly because they have diversity of structure, which with range of coordination number from 4 to 7. Besides, they have unique molecular geometry, for example, tetrahedral, which this could result in a propensity for ligand exchange. These all properties could contribute to their biological activity, including anti-tumor, antimicrobial, and antifungal. The biological activity of organotin compounds is presented as the following, which triorganotin are said to have the higher biological activity compared to other organotin complex. On the other hand, dithiocarbamate is chelating ligand, which is widely used in organic chemistry due to their interesting electrochemical properties. In cytotoxicity, organotin are said to cause the cytotoxicity, while the ligand help to facilitate the molecule to the target and addressing it while preventing any unfavorable alteration in the molecule. Generally, there is no specific method to synthesize the organotin dithiocarbamate compound. However, the instrument method is suggested the best way to synthesize this compound, since the ligand is unstable at temperature above 4 degrees Celsius, and the ligand dithiocarbamate and organotin salt will be prepared according to the following ratio. The organotin dithiocarbamate complex can be characterized in the elemental analysis CHNS, which the main element in the organic compounds can be determined in this analysis. Next, in the spectroscopy analysis FTIR, 4 important absorption regions can be observed, which the formations of the dithiocarbamate can be observed in 2 regions, which is carbon nitrogen band and carbon sulfur band. In the carbon sulfur band, a single peak indicates the bidentate coordinations, while a split peak indicates the monodentate coordination. The formation of organotin dithiocarbamate can be confirmed by observed in the regions of stannum carbon and stannum sulfur band. In the nuclear magnetic resonance spectroscopy, the hydrogen NMR can be categorized into 2 chemical shifts, which is for dithiocarbamate ligand and also organic group attached to the stannum atom of non-aromatic groups and the phenyl groups. For the carbon NMR, the CS2P of the thiouretate carbon can be observed. In the stannum NMR, the coordination number and the geometrical structure can be predicted, which the coordination is range from tetra, penta, hexa, octa, or pentagonal bipyramidal. In the X-ray crystallography, the 3D structure of the compound can be determined, which the organotin complex are said to have a common structure of tetrahedral, octahedral, or triangle bipyramidal. Here is in the diagram distorted tetrahedral, which this geometry are commonly found in the triorganotin complex. The individual properties of organotin dithiocarbamate moieties create a synergy of action in the hybrid complex, thus increase their biological potential activities in the biomolecule. Tin and platinum atoms are said to have similar chemical characteristics, which organotin exhibit electrophile properties that can interact with electron donor groups in the biomolecules. Therefore, they are said to have high cytotoxic effect on various cancer cell lines. Triorganotin complex is the most active compound in this series, which the tetrahedrally coordinated and shortest alkyl chains of triorganotin gave the highest cytotoxicity. This mainly because they have low coordinated tin atoms, which cause more exposure of the tin atoms with the donor atoms of the molecules in the target cell. The ligand dithiocarbamate, upon chelating to metal ion, they reducing the polarity of the metal ion, increase the lipophilicity of the metal ion to pass through the membranes to the cellular environment. That's all from me. Thank you for your kind intention.